Hi, everyone. My name is Taylor Herbert. I am a graduate student at Texas A&M University in the Agricultural Leadership, Education, and Communications program. Today, I'm going to be providing an overview of the innovation development process. So this process is a part of the Diffusions of Innovations theory. It is by Everett Rogers, and we are going off the 5th edition. But before we jump in today, I want to make sure we are all on the same page with our learning objectives. And so those are going to be understanding the innovation development process, also identifying which step of the process an innovation is in through observation of that innovation, and then recognizing the significance and shortcomings of tracer studies. So the diffusion of innovation theory, as I said, is coming from Everett Rogers. He has written many versions of this theory, this book, but the latest one being in 2003. I want to make sure that we're all on the same page as far as our general and foundational knowledge of the diffusion of innovation theory before we move into the innovation development process and what all that entails. So I'm going to start off by watching this short video. So just a second here as we get that pulled up for you.
Innovation is such a fascinating topic, but how does it actually get adopted? Believe it or not, but in order to answer this question, we look back at a theory that was developed more than 50 years ago, and it's called the diffusion of innovation theory. Herbert Rogers, the author of this theory, proposed 5 stakeholder groups that explain how innovation gets adopted over time and by different cohorts. The first group we call the innovators. These are the 2.5% who are out there literally sleeping in front of the shop to buy the innovation the day it comes out without being road tested. The second cohort is made up of early adopters, roughly 13.5%. The early adopters are the immediate second wave. The first buzz is over, the product is maturing in its abilities, and the early adopters get pleasure and satisfaction out of early usage. The early majority represent the third group, that is the next 34%. The product becomes widely known and mainstream, and the early majority group are those guys who ride this mainstream adoption. The fourth group, or the so-called late majority, is far more cautious. They represent roughly 34% and will wait, typically for decline in pricing, until first hiccups are ironed out, and only then will adopt the innovation. The very tail end, the fifth and final group, consists of so-called laggards. Laggards are the most reluctant, but finally they will get over the line and make up roughly 16%. Think about laggards and those guys who only now sign up for e-banking or maybe the internet. If you map these 5 cohorts of the diffusion of innovation theory over time, and according to these percentages, it will form a bell curve. If you now sum up this information across the bell curve, you reach the well-known S-curve. The S-curve, in 4 stages, describes how innovation is adopted in terms of its speed of adoption. At the very first stage, where there's very low growth, we see almost every startup entrepreneur on this planet. A lot of trial and error, a lot of prototyping, and many of these innovations will never see the light. If an innovation takes off, it ideally takes off in an exponential fashion. Exponential growth is what we see right now in many solutions, for example, Uber and Airbnb. Rapid growth rates, and typically then we call them disruptive innovations. Once exponential growth is over, we enter the stage of slowing growth. And after that, we see a plateauing. Examples for plateauing over the last 5 years were analog photography or DVD players. So you can see how the diffusion of innovation theory, the 5 cohorts, can be mapped to the S-curve and allows us to understand who, in what sequence, and at what speed adopts innovation.
Perfect. So now that we are all on the same page with the diffusion of innovation theory, we can move on to the innovation development process and what all of that entails. So the innovation development process is a process that was deemed by Rogers in 2003 and his earlier editions as well, and in the book Diffusions of Innovation. So it is 6 steps. You can see this image on the slide, 1 through 6. And typically an innovation has to start at 1 and go through this process to really be adopted and become a thing. So we talk about the rate of adoption and diffusion and all those things, but Rogers is really telling us with this process that before you can even get there, an innovation has to really go through all these steps and have these different processes happen, because the origin of where these ideas and innovations come from matters, and they affect the different stages down the road. So we're going to go through all 6 of these, each individually. And the first step is recognizing a problem or need. So for step number 1, it's all about what problem or need that someone's seeing or is noticing is going to happen in the future. What problem or need is going to set in motion investigations and research to find a solution to those problems or needs. And that's going to be the innovation. The solution to that problem or need is going to be the innovation. So a problem or need can be something that someone recognizes through scientific expertise or political forces. It doesn't just have to come through what we know as basic research in a scientific field. It can come out of social problems as well. So things like policy changes and needs within a societal problems. And it's also important to note here, we're calling these steps, they are step 1 through 6. However, Rogers did note that it should be a linear process. Innovations typically go through these steps in a linear process, but they can happen differently at different time frames, and sometimes they don't happen at all. So step number 2 is going to be basic or applied research. And so, as we were just saying, sometimes problems or needs come through scientific expertise and research, and sometimes they don't. So in that case, the process wouldn't be as linear, and maybe they would skip step number 2. But basic research is the original investigations for the advancement of scientific knowledge, and they don't necessarily have a specific objective that they want to apply the knowledge to solve a practical problem. It's just basic research. But on the other hand of that, applied research is intended to solve practical problems. So you can see that basic might be more in that, or is more in that scientific expertise, and applied research is more in that social change area. So innovations can go through basic and then applied research, and they typically do. So a little bit of basic research and then applied research, and then they move on to the third step, which is development. And then a really important thing to note in this step is the fact of serendipity. So that's a fun word to say too, but serendipity is actually accidental innovations through research. So someone could think that they're doing basic research for a specific end goal, and really they come across something happens, or they come across a discovery that ends up being an innovation as well. And so that would be considered serendipity. Or you're doing applied research and you find some things that you weren't intending to find, but those things did happen, and that would be serendipity. So that's, again, really cool word to say, and I think also a really cool way to look at innovations, because they're not always planned out or supposed to happen. And then another important point in step 2 of the innovation development process is the term lead users. So a lead user is an individual who develops innovations when they have or see a need. And so this is going to fall more under that applied research area. This is when someone is either observing a population, or maybe they're doing a project themselves or doing something themselves, and they're like, man, it would really help me, or it would really help that group of that population if they had X, Y, and Z. And so those lead users are going to be those people who take the initiative to say, this is an innovation that I see a need for, and they're going to take that initiative to start that. Typically, lead users are people who create or come up with that idea or innovation, but then eventually they take that to manufacturers and companies to actually develop, which is step number 3, but they actually develop those products, because the lead user is typically just an individual or a small group that doesn't have the resources to actually develop and move forward with the production of those innovations. Step 3, as I said, is development. So this is the phase where the innovation actually finally becomes something in a form that is usable. So you could say it comes to life in this phase. So before it was research, it was ideas. Now it is a physical or actual concept and thing. So in the development phase of this process, the role of uncertainty plays a big part. So this is where those individuals, those companies are really putting their ideas and thoughts to pen and paper and to physical objects. And so they're now faced with the fact that people are going to be out there thinking about all the ways that this innovation could fail. They're going to be out there, trying to adopt it, use it, all those things. And so they have to take into account there could be competitors for this innovation. There could be government policy and other things that are really kind of against them, or they have to think about all the things that could be affecting their adoption and diffusion with this new innovation. And so with that, it's really just the uncertainty that comes with all of that. Another critical part here is information exchange. And so the way that individuals and companies exchange their technical information in the face of that uncertainty is really important. They want to be able to not only explain the innovation well, but they want to have basically as many answers as possible. They want to be able to present their innovation with as little question as possible to really bring down uncertainty as much as possible for those that are going to be adopting it. And so with that, we'll get into in just a minute about the way that they diffuse innovations, like who gets that information first and how they do that. We'll get into that in the next step, but information exchange is critical because if they are maybe using really technical words that those that are going to be adopting don't understand, if they are really just not being able to explain the why and the what of that innovation, then adoption is going to be slower. It's going to be more uncertain, which is going to cause people not to really get there with their innovation. So the information exchange needs to be good and concise and all there. So a fun thing about the development process is a Another fun word to say, like serendipity, skunk works. So skunk works are specialized environments that are intended to help a small group of individuals design a new idea by escaping routine organizational procedures. So what that means is sometimes when you're coming up with these new ideas and you have these innovations, your actual organizations and jobs and things like that are too structured and have too many roles and things in place and too much time structure, and you have too many other responsibilities that you can't actually focus the time, energy, and resources you need to on that innovation to make it become a thing. And so skunkworks is actually a term that came from the World Wars, and it was the same concept for that, but in terms of war. But here it's where you can't it's where individuals and groups make these specialized environments. So they set up a spot that they can strictly work on the innovation however they need to without all of the rules and procedures that typical companies and businesses and those things would have during your typical workday. So it's a way to really get that development process thought all the way through and done. So for the next bullet, technical transfer. So this is the application of information to use. That's how Rogers defines it in his book, Diffusion of Innovations. So what that means in a different way of saying it is a two-way communication exchange. And so technology transfer is not just about actual technology, but it is communication. So the three things that go into that are knowledge, use, and commercialization or organization. So having the knowledge of an innovation is the person, the receptor or group, person or group. The receptor knows about the technological innovation. So knowing about it and using it are two different things, right? So the next step is use. So the receptor now has used innovation. And so they not only know about it, but they know all the ins and outs, they know how it works, things like that. And then the next is commercialization. So now the receptor has commercialized innovation. So this stage requires a lot of resources and interpersonal communication about the innovation, and it will be over a period of time. But that is how the technology transfer works. And once the product is developed, that's where you get into that knowledge, use, and commercialization. And so actually our next step in the whole process is step number 4, commercialization. So this is the part of the process where your idea and your innovation had been researched and applied. That research was addressing a need, and then we move to the development stage. Your product is now developed, it's actually a real thing, and now we're at the stage where the innovation is a product and it's ready to be sold in the marketplace. So again, I wanted to note that new products can come specifically from research, but they can also come from practice. So if you saw a need in society and those things, and you developed that innovation, then you would go through the process, but eventually you would still get to this same step of commercializing your innovation. Like I said, now it is a real product. So the development stage is where patents and all of those things come in, and commercialization is where marketing materials and all of that information that you need to get out to the public to market your product comes into play, so that your product can be ready to be adopted when you're selling it and when it's out there into the target audiences. An interesting thing about commercialization is technology clusters. So I found this really interesting because later when we talk about tracer studies, you'll also see this again, but technology clusters are when not only one innovation is released or diffused into the population, but when multiple are diffused at one time. And so we'll talk about tracer studies in just a second, but it's actually interesting that technology clusters can be more effective in the fact that there's multiple innovations and multiple technologies getting out there at one time, and people are just more receptive to that. So technology clusters are also known as innovation packages because, like I said, they come in groups. So that is commercialization, and we will move on to step number 5, which is actually diffusion and adoption. So there are a lot of steps that come before actually adopting an innovation. But for diffusion and adoption, it begins with the sharing the innovation with potential adopters. So this is what I was talking about a few moments ago, about that information sharing, that information exchange being so critical. And it's so critical that they created something called innovation gatekeeping. So this is controlling who the innovation is diffused to first, or who it's diffused to at all. But typically with diffusion, you want to start with people who you know are potential adopters. So if those potential adopters are receptive to the idea and they adopt the innovation, then it can go further into the other target audiences and the other, like the rest of the population, but the potential adopters have the least risk. So innovation gatekeeping is keeping your innovation and your product a little bit disclosed. Not everyone knows about it yet, but a pool of people who probably will latch onto it do know, and then from there it can go wider, instead of it dying with a just broad diffusion. So with that, diffusion can happen in waves. So you could have your potential adopters, diffusion happen with them first, and then once they adopt, it could go further. But it also could just happen in an overall blanket approval. So an example of this is definitely clinical trials in medical fields. It's also another example is the military, but clinical trials have to be have to use innovation gatekeeping because of the risks that come with, human life and testing on them and not knowing the whole consequences, things like that. So you want to start with innovation gatekeeping and then go forward, instead of just diffusing that new innovation to the whole population. Step number 6 is consequences. So this is an interesting one as well. The consequences step is just talking about how any changes that occur to an individual or social system as a result of the adoption or rejection of the innovation, that's the consequences step. So you're seeing things like, did this result in anything negative? What are the positive results of this? These can be intended consequences. They can also be unintended. So, and this could be things that happen to specific people, specific groups of people, or it could be something that changes in the whole society based on the innovation that was diffused and adopted or rejected. One part of step 6 is socioeconomic status and equality. So depending on the target audience that an innovation is meant for, it can have effects on the socioeconomic status and the degree of innovativeness of a society. So innovations can cause inequality because if, let's say the development of electric cars. So if those are high priced and those lower on the, with a lower socioeconomic status can't afford those innovations, they can't afford to purchase those, then that's going to cause a bigger gap in our equality. And so it's going to cause inequality because it's putting a bigger gap in our socioeconomic statuses. And it also has an effect on how the innovation development process is handled. So it depends on the purpose and the target audience for the innovation, for sure. So that can definitely be a negative thing, and that falls under our consequences step. And then the next thing that we're going to talk about is tracer studies, and while these are important, while they're significant, and also their shortcomings, but tracer studies are research devoted to studying the research, development, and commercialization steps of the innovation development process to understand the main events and decisions throughout the process. So these studies are studying how the innovation development process happens, and then the main things, the main decisions, main conversations, main events throughout the process. So studying the innovation development process. So when it comes to understanding tracer studies, there are 4 main takeaways that have been gathered from tracer studies in the past. So the first one is that tracer studies showed that applied research contributes more to creating innovations. So this comes from Project Hindsight. It's an example in Rogers' Diffusion of Innovation Theory. And so instead of it being basic research that really causes more innovations, it's really the applied research, which is more practical and less scientific research. The second thing is that studies show that technology clusters have been used for major technological advances. So this is what I was talking about earlier about how cool it is that when an innovation comes out, when it's developed and commercialized, it's typically in technology clusters instead of one at a time. And so those studies have shown that when those innovations come out in technology clusters, people are more receptive to those. The next is that these studies show that a lengthy period of time, 20 plus years, occurs between basic and applied research in military and medical innovations. And so again, that's what I was talking about regarding clinical trials when it comes to innovation gatekeeping, because sometimes it can be lengthy amounts of time that these things are going through this innovation development process. It's not on a certain time frame. It's not, it doesn't depend on anything but just how the research is going in those specific innovations and how they're going through the process. So the next thing is that tracer studies show that research is often started without a specific social problem in mind. And so that means that this basic or applied research, when it started, there isn't a specific problem in mind, but things come out and problems come up during the middle of that research. And so these things are normally involved with serendipity. And so that's just accidental discoveries of those research and those problems and needs that are arising. Now, when it comes to tracer studies, there are some shortcomings, and these are also very interesting to see because at first I was like, wow, these tracer studies, they're really onto something. But when you look at them, these are the shortcomings that you really have to take into consideration. So the first is that the tracer studies are retrospective and they only rely on reconstructing the process. And so a lot of times these studies are rely on interviews and people recalling things and recounting how the innovation development process went. And so especially if this is a long, lengthy period of time, like 20 years, relying on reconstructing the process, it can't be as reliable as you would want it to be, right? So we really want to try to make these tracer studies a more prospective thing, and really not have to rely so much on retrospection. So the next shortcoming is that the tracer studies focus on the first half of the innovation process, the innovation development process. So that is the research step, the development step, and commercialization. But no tracer studies have gotten to where they investigate the diffusion and adoption step or the consequences step. And so that can really be misleading as well, because those are also huge parts of the process. One could argue those are some of the largest and most important parts. So those things really need to be researched as well when taking into consideration how the process goes. And the last one is that tracer studies rely on the assumption that whatever research and development happened was completely thought out, planned, and was going to occur. They do not take into consideration that serendipity not only occurs, but serendipity occurs a lot. And so they don't account for that, and they're relying on assumptions of planning and organization and things that maybe they should reconsider, as well as take into consideration serendipity. That is the end of my presentation, and I really hope that you look back at those learning objectives and can identify each one of those as we've gone through the presentation. So hopefully you're able to have an understanding and be able to analyze the whole process as a whole. You're able to understand tracer studies, the shortcomings and the significance of them. And hopefully you're also able to recognize and discern innovations in the real world when you're observing those in the real world, and be able to say, this innovation is in step 1, 2, 3, 4, 5, or 6 of the innovation development process. So thank you so much for your time. But I do have just one thing after my reference pages. Those references are listed here. I want to see what you've learned. So if you'd like, please go ahead and click on the knowledge check button there. It'll take you to a Google form. It's just a knowledge check quiz with a few questions over what we've gone over today. So again, thank you so much, and go out and be change agents. So thank you.